Let's take a look. 6.11, parabola key features. Now, I do want to just start with, do we remember the word parabola from last year? If we remember it, give me a thumbs up. If we don't, give me a thumbs down. Thumbs down. Again, if we... Oh, there just shouldn't be side conversations. All right, I've got a few hands that have said we maybe remember this. Okay. I do see the bathroom hands. You can put them down. Thank you. In order to talk about this, considering this looks like it's maybe new for a lot of us, just make sure that heads are up, please. A parabola is the shape of a quadratic when it is graphed. Right? And so anytime we have something that looks like ax squared plus bx plus c, and we graph it, we have this parabola. Now, interchangeable with parabola is going to be curve. You can call it a curve, that's totally fine. The one word that I really want us to move away from now is line. This is not linear. We do not want to call this a line. It can be curved, it can be full parabola, either one works. Now, this is, for right now, a strong enough definition for us, but know that a parabola actually has a lot of really cool specific features. Things like communication dishes, anything that gets broadcasted. Physics see parabolas a lot because they have very special focal points, which is different than any other just like ordinary curve. Now, if we're going to start talking about things, I actually want to start with something that we definitely know. This point right here, right? You already have an arrow to it. What would we normally label that as? What is that hitting?
That's the y-intercept.
Yeah, that's the y-intercept. That's our y-intercept. And if that's our y-intercept, let's actually go up to that middle box. What is that pointing at? Or what are the two things that that's pointing at then? Yeah, those are x-intercepts. I want to put heavy emphasis right now on how important x-intercepts are when it comes to graphing quadratics. In the way that we would often use the y-intercept to help build the line for like linear equations, right? We had a b value which told us our y-intercept. X-intercepts can build an entire quadratic equation. In fact, we've actually done it a few times. We just aren't aware that we've been doing it. And so before we move too far away from these, I also want to note, instead of the b value, our y-intercept is now our c value. Right? And so if we're thinking about y equals ax squared plus bx plus c, anytime we substitute in 0 for x, all we have left is just c. And so our y value, or our y-intercept, is always going to be the c value. From here, if we are not as familiar with parabolas, these next two might be new for us, and that is okay. This top box pointing to the dashed line, this is the axis of symmetry. The axis of symmetry. Now, what does it mean for something to be symmetric? Yeah, it's the same on both sides. And so literally, if you look at the left-hand side of this and the right-hand side of this, they're doing the same thing. It creates a lovely mirror image of itself. And so that is our axis of symmetry. And then all the way down, last box, this is our vertex. That point is a really special, important point. It is called a vertex. The vertex of a parabola is oftentimes the subject of Regents questions, SAT questions, any sort of standardized test. It comes up a lot. It can tell you a lot really quickly. So we have everything labeled. Let's quickly define these. Axis of symmetry. The vertical line. That splits. The parabola in half or in two, either one. Your axis of symmetry always goes through the vertex. If your axis of symmetry does not go through the vertex, it means one of three things. One, your axis of symmetry is in the wrong spot. Two, your vertex is in the wrong spot. Or three, both of them are in the wrong spot. They need to be in line with one another. Anytime we talk about an axis of symmetry, the answer is always written as x equals some number. We'll see that that's really specifically just the x value of the vertex, but it needs to be x equals. Again, the axis is a vertical line. You need to write it as such. This is going to be really, really similar to when we would talk about y-intercepts, and like some people might just see like the number, and I would say no, and then we change it to the full coordinate point. Same thing here. Axis of symmetry is not just the number, it is the full equation. Now, the vertex, this is the highest or lowest point on the curve. The highest or lowest point on the curve. The vertex has a few different names, although it's not as interchanged as some things like x-intercept, which we'll talk about. But the vertex can be called the maximum, the minimum, or sometimes the turning point. The maximum, the minimum, or the turning point. Turning point's fairly literal, right? If you were to trace this with your pencil, it's where you literally have to like turn around. As we continue on this unit, we'll also talk about the fact that it's also where it changes from either decreasing to increasing or increasing to decreasing. And so again, like that phrase turning point will come back up. And now the x-intercept. Now, the x-intercept is a fairly familiar definition, but we're actually including one slightly new piece to this. This is where the curve crosses or touches the x-axis. The sort of phrase that we're adding here is that it can touch but not cross. And so if I have my axes like this, and my excuse me, my parabola comes down and maybe just hits 0, 0 right here but doesn't cross, I would still consider this an x-intercept. It did not go past it, but it does not need to anymore. It can basically touch or dip down, touch it, go back up, or it can come up, touch it, and go back down. Both of those are valid for x-intercepts. I'm just going to have us do a quick posture check. If heads are down, please make sure that heads are up. The x-intercepts also get, honestly, like a lot of different names. We're going to add 2 of them today. X-intercepts are also called roots or zeros. If you see the word roots or you see the word zeros, it means x-intercepts. Those 2 right now are, or I guess 3, are interchangeable. Fair game for you to hear any of them. Honestly, as I often talk about them, I also will refer to them differently, just based on whatever. I generally go for roots because it's the least amount of syllables. Now, before we move too far away from this, I do want to like actually label then what are the values that we just defined. And so for the vertex, what is that coordinate point that it's pointing at? What is it? Ooh, not quite. It's not quite 0, -4. What's the x value? Quinn, was it? What'd you say? 1. And so this is 1, -4. Vertex is always a coordinate point. Vertex is always a coordinate point. Vertex, always a coordinate point. I say this because now I'm going to go up to the axis of symmetry. Where is the axis of symmetry? It's at what? 1. However, that's not the answer, right? Because how do I always have to write this based on the definition we gave? You have to write it as an equation of the line. And so what should I write? Not just 1, but what? X equals 1. This number and this number should always be the same. If your axis of symmetry goes through your vertex, it's always just x equals the x value of your vertex. That's it, every time. Flip your notes. Let me finish. I'm going to start sending people again. This part's much faster. Okay, so for this, all we're going to do is finish the table. We have an equation, y equals x squared. We have a bunch of x values. What do I have to do to find y? I have an equation, and I have a bunch of x values. So what do I do with those x values to find y? Not quite multiply or divide. I square them. If it says y equals x squared and I have a bunch of x values, I'm going to square each value, right? It's substitution. It's the same thing that we would normally do. And so for this first one, right, y is equal to -2 squared. It's really -2 times -2. What's a negative times a negative? Positive. Positive. Well, so what's 2 times 2? 4. And so +4 goes here. I need the side conversations to stop. I'm not going to do these with the rest of the x values. Now, I'm not going to write them down because, again, like literally all we're doing is squaring. What's -1 times -1? 1. What's 0 times 0?
0.
What's 1 times 1?
1.
What's 2 times 2?
12.
What do you notice?
They're all the same. They're repeating.
So they're repeating, and to Tate's point, right, like it's sort of the same both ways. And so, again, if we think of that word symmetry, right, whatever happened on the left of the 0 was the same thing that happened on the right side of the 0. Now, we're just going to graph this. We're going to use these pairs as points. And so first one, -2, 4. -2, 4 goes right here. Second one is -1, 1. Then we have 0, 0, 1, 1, and 2, 4. Now from here, I'm going to draw on my curve. Now, I always start at my vertex and go to either side. Like that. You want to try and just have as much as a curve there as possible. The key here is like when we draw these, you just don't want a V. A V is a really specific type of function for absolute value. That is not what this is, so we want that bottom part curved as much as possible. Now, same thing, only with the second equation. What's changed? Example 2, what's changed? yeah, you get the negative in front, right? And so I'm going to take all the squared values, and I'm going to make them what? Negative. Right? What's negative 2 times negative 2? 4. Now make it negative. Negative 4. Because again, this would be y is equal to the negative of negative 2 squared, which is the negative of negative 2 times negative 2, which gets us to negative 4. All right, what's negative 1 times negative 1? Oh, hang on, careful. You're just one step ahead of me. What's negative 1 times negative 1? 1. Make it negative. 0 times 0. Do I have to worry about making that negative? 1 times 1. Make it negative. 2 times 2. Make it negative. And so again, we see this symmetry happening. Going to do the same thing. Going to plot each of these. Negative 2, negative 4 goes there. Negative 1, 0, 0. 1, negative 1, and 2, negative 4. And so now when we draw this, instead of our arrows going up, they're going in what direction? Down. This is really important to be able to identify. This actually tells us quite a bit about the parabola if we can identify if it is what we call open up or open down. So on both of these, they actually share a vertex. What is the vertex for each of these? 0, 0. It's 0, 0. And so for this first one, I'm going to name, yes, this is 0, 0. But for the first one, or the blue one that's up on the board, is that vertex a maximum or a minimum? It's a minimum, right? This is the lowest point on the blue curve, and so this is a minimum. And this is, I already sort of named it, what we call open up. Now, on the second one, vertex hasn't changed, right? We named it's still 0, 0. However, is it still a minimum? It's a maximum. How'd you know? There it is. This is a max. All right, and so if the first one is open up, what do you think we would call this? Down. Not quite. Sorry, I don't think I set that up well. We just say open down. First one is open up. This is open down. Now, these two are not independent. I'm going to name right now, if it's open up, your vertex is always a minimum. If it's open up, your vertex is always a minimum. If it's open down, your vertex is always a maximum. And if you have a minimum, that means it's open up. If you have a maximum, it means it's open down. There's no like picking and choosing like, oh, I have a minimum, but I'm also open down. It doesn't work like that. And these come from one very specific piece. What did we say was different between these two? Sorry, what do we say was different about the equation? I heard it say again. Yeah, it's the negative. In example 1, if we were to go back to our standard form, a, or the coefficient on x squared, is just what number? 1. On the second one, coefficient a is really what? Negative 1. This has everything to do with it. Minimum and open up only happens when a is positive, and always happens when a is positive. Does not matter what the positive number is, as long as it is positive. Conversely, maximum and open down happens every time a is negative. Again, doesn't matter what number it is. It could be negative 1/2. It could be negative 3. It could be negative 8 million. That parabola is open down. What questions do we have? All right, then we're going to spend some time practicing. I want you to fold your notes and get them glued into your notebook, please. You got 1 minute. Go.